In exercise 1810, they're asking us to predict whether a compound is going to be aromatic, non-aromatic, or anti-aromatic, and to explain our reasoning. So we're going to use that process of thought that we developed in the video on the concept of aromaticity, non-aromaticity, and anti-aromaticity. And the first question in that process of reasoning is, are there parallel p orbitals on every atom in a ring? So here, because of the conjugated pi system, there are parallel p orbitals on every atom in this ring. Anywhere where you have a pi bond, here all of the double bonds, you have parallel p orbitals on adjacent atoms. That's how you get pi bonds. And since you have conjugated pi bonds all the way around the ring, every single atom has a parallel p orbital. And so the electrons in those p orbitals can travel all the way across the atom in the delocalized waves that travel over the entire molecule in molecular orbitals. So it is. So the molecule is either going to be aromatic, especially stable, or anti-aromatic, especially unstable, because of the types of waves it can form. Now, what waves it forms depends on how many electrons it has and how many wave patterns it has to fill. If it has a Huckel's number of electrons in the p orbitals, that's 4n plus 2, if it has a number that's in that pattern, if it has a number that you can get by plugging an integer in for n, a whole number in for n, in that case, it will be aromatic. And if it doesn't have a number that's summarized by that pattern, then it'll be anti-aromatic, especially unstable. Let's get rid of these p orbitals just so we can see the number of electrons we have a little more clearly. Here we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. There are 22 electrons in p orbitals in that ring. So is 22 a number that you can get by plugging in a whole number in for n? And it is. If you plug 5 in for n, then you'd have 4 times 5. Remember, the n does not represent any physical thing. It's summarizing an infinite series of numbers with an algebraic expression. So if you plug 5 in for n, you'd have 4 times 5 plus 2, that's 20, plus 2, that's 22. So 22 is a number in this series, and that means that this molecule is aromatic. It's especially stable. So, explain our reasoning. Well, this is aromatic because there are parallel p orbitals on every atom in the ring, and there are 4n plus 2 electrons in those p orbitals, so that all of the electrons will fit in low energy molecular orbitals.